Hi guys, so this is a new video on differentiation under math studies. This video shall serve as a general review and I shall tackle the 3 questions on the screen. I shall begin question 1 short. So question 1 came in paper 1 November 2011, question 14. Kindly take a minute and attempt to solve. The answer shall follow through shortly. So in question A, I'm required to differentiate f of x equals 1 over 3x cubed plus 2x squared minus 12x plus 3. This is pretty straightforward and we've been through it. So f dash of x is equal to this blue expression and simplifies to x squared plus 4x minus 12. For question B, I'm required to find the interval of x for which f of x is decreasing. Now, f of x is decreasing means that it has a negative slope. And hence, since the slope is negative, I shall deduce that f dash of x is less than 0. F dash of x has already been obtained as x squared plus 4x minus 12. So what I need to do is I need to find the interval where this expression is less than 0. I shall use the GDC to do that. So I've typed down the function onto the GDC, the red function x squared plus 4x minus 12. And I shall click on trace to get the graph of the function. Now I want the interval where the function is less than 0. So obviously I'm looking at this portion of the graph right there. So this portion starts at this point and ends at this point. So whatever lies between these 2 points, this entire region, is negative. So I need to find the x values of these 2 points in order to find my interval. Now these are x-intercepts, so they are found by the 0 operation. So I'm going to press on second, trace, 0, and for each of the points I'm going to calculate the 0 or find the 0 by getting the left bound as we did before and the right bound and a guess for where the point is. So, excuse me, this was a mistake. So let's try this again. Here is my curve. I'm going to press on second, trace, 0. I'm going to get the left bound. And the right bound. And a guess. So the calculator tells me that the first intercept is at x equals negative 6. As for the second intercept, I shall repeat the process. Second, trace, 0, left bound, right there, right bound, right there, and a guess. And the calculator tells me that the second 0 lies at x equals 2. So whatever lies between negative 6 and 2 for the values of x is negative for the value of y. So y is negative in the region that extends from negative 6 to 2. Hence, my answer to the question shall be expressed by the inequality negative 6 less than x less than 2. So take a minute to copy this down if you will, and I shall begin the second question shortly. So the second question that we shall tackle in this video came in paper 1, May 2007, question 11. Take a minute and attempt to solve. The answer shall follow through shortly. So in question A, I am required to differentiate f1 with respect to x. f1 equals x, hence the derivative shall obviously be 1. And to differentiate f2 with respect to x, and the derivative of this function is obviously negative 2x. So these are the answers to AI and AII. Moving on to B. So in question B, I'm required to calculate the value of x for which the gradient of the two graphs is the same, and I know that the gradient is f dash. Hence here I want to find the value of x for which f1 dash is the same as f2 dash, and this is what I shall do. So f1 dash equals 1, f2 dash equals negative 2x. They are equal to each other because the gradients are the same. Hence 1 equals negative 2x and x equals negative half. Moving on to question C. I am asked to draw the tangent to the curved graph for this value of x, which I obtained in B, showing clearly the property in part B, which is that the gradient of the two graphs is the same. So since the gradient is the same, the tangent I'm going to draw is going to have to be parallel to the line f1. So I'm going to draw a tangent at x equals negative half, which I got in B, parallel to f1. And it should look something like this. This is the marking scheme version of the answer, and you get 1 mark for a tangent drawn at x equals negative half, corresponding to your answer to B, and a reasonably parallel line to f1. So it should kind of look parallel to f1. It doesn't have to be ruler based, it doesn't have to be exactly parallel, but it should be kind of parallel and located at x equals negative half. So I hope that you have understood the solution to this problem. Take a minute to copy the answer down if you will, and I shall begin question 3 shortly. So the third question that we shall tackle came in paper 1, May 2011, time zone 2, question 11. Take a minute and attempt to solve. The answer shall follow through shortly. So we are given two functions, f of x and g of x, and in A we are required to differentiate f of x. So let's take a look. Since f of x equals 1 over 4x squared minus 2, f dash of x shall equal 2 over 4x, which I obtained by multiplying the 2 by the 1 over 4 and reducing the power of x by 1. Obviously, the second term vanishes during differentiation. Now moving on to question B. I am required to differentiate g of x with respect to x. G of x equals x, so obviously the derivative is 1. So g dash of x equals 1. Moving on to C. I want to calculate the value of x for which the gradients are the same. So like the previous question, we shall equate f dash and g dash and find the value of x. So 2 over 4x equals 1. I equated the red and blue expressions, and this gives me that x equals 2. Now moving on to question D. I am required to draw a tangent at the point with the value of x found in part C. So the value I found at C was that x equals 2. This is the point where the gradient of the two graphs are the same. So I'm going to draw a tangent to the curve at x equals 2, and I should draw the tangent parallel to the line g of x, since parallel lines have equal slopes, and if I know that the gradients are the same or the slopes are the same, then I know that the two lines are parallel. The two lines are the line g of x and the tangent to the curve f of x at x equals 2. So the drawing should look something like this. You shall notice that the marking scheme drew the tangent at x equals 2 as we've mentioned, and that the two lines are roughly parallel, the tangent to f of x and the line g of x. So you get one mark for a tangent drawn at the correct coordinate, which is x equals 2, and a parallel tangent to the graph of g of x, which is the line already drawn. So I hope you have found this easy to understand. Take a minute to write this down if you will, and this concludes our video. Thank you.